We are BME Senior Design Team 3. Our advisors are Dr. Yu and Dr. Soikin. We are sponsored by Dr. Smees at Kohler, a premium brand known for its high-quality kitchen and bath products. The team was tasked with researching and testing additives. Additionally, two device prototypes were developed to accurately dispense the appropriate concentration of additive to ensure effectiveness. It is important to Kohler for the user to have a precise luxury experience with ingredients that have proven benefits.
In the first semester, research was covered for 39 different bath additives, focusing on the effectiveness, cost, risks, and recommended concentrations. Based on findings, the team created a matrix to provide Kohler with recommended additives to further test, planning to perform tests on soybean and coconut oils in the second semester.
The device prototypes were then chosen through selection criteria, including controlled concentration, sustainability, ease of use, cost, ability to mix additives, and size in that order of weight. Two devices were selected based on the criteria, and moving into the second semester, the team began prototyping.
The first prototype developed was Sylvie. It utilized a flow restrictor and bulk erosion properties to deliver bad additives into the bath through soaps. The device needs to follow ADA 404.2.9, which states that the doors must have 5 pounds or less of opening force. The soaps were created with different additive bases to use on Sylvie, and the erosion rates were tested. The tablet volume variation graph demonstrates consistent dissolution at different time intervals, showing stable performance over time.
The second prototype that we developed is Vima. Vima uses a sensor strip that hangs over the side of the tub wall to read the water level and delivers the correct volume of additive based on the reading. Currently, the device is designed to fit a standard Kohler bathtub, but future designs can be developed to fit other tub models. The standards that are important to follow when designing our device are UL 1431, UL 943, and IEC 60335-241, which ensure proper installation and safety of electrical devices. The delivery of additives on Vima was tested at different resistance thresholds to determine the precision and accuracy. As the resistance threshold was lowered, the device became more accurate and precise in its delivery.
Hydration testing was conducted using a Delphin moisture meter on the backs of our hands. We tested the hydration levels of soybean and coconut oil with both devices. It found that soybean oil in both forms did not provide skin hydration. The positive control soap showed an increase in hydration compared to other groups, which is likely because it was an olive oil base.
The results of the coconut oil test showed that coconut oil in its extracted form did provide skin hydration. These results were from preliminary testing on team members from Kohler's design projects, and the sample sizes for these tests are very small. Further testing is needed to improve statistical accuracy of results.
Sylvie was able to meet half the expected criteria, succeeding in sustainability, being in the best cost range, and having a high ability to mix additives.
Vima was able to meet most of the criteria, with the exception of its ability to properly mix additives into water.
Future improvements for Sylvie involve a new flow restrictor due to backflow issues. However, this may even be solved using a process other than 3D printing. It is important to note that Kohler wants the device to have a more luxurious design.
For Vima, future work will include the development of a user interface and designing the exterior to be luxurious and adaptable to different bathtub styles. Thank you to our advisors and our sponsor.